Hi, in this video I want to talk about a new Java control structure called while loops. A while loop repeats blocks of code, and we want to understand the syntax of a while loop, in other words, how you construct a valid while loop statement. We want to know how the computer actually evaluates a while loop. We want to see some situations where a while loop can be used. So, while loop has the keyword while, followed by a Boolean expression in parentheses, and then a code block, either a single line of code or a curly brace code block, and the statements inside the code block repeat as long as this Boolean expression is true. In order to evaluate a while loop, Java first encounters while loop. It tests if the expression is true. If it's false, it actually just skips over the statements altogether and moves on. If it is true, it executes the statements, comes back up, checks the Boolean expression to see if it's still true, and then repeats or goes on as the outcome of that. So one thing to note is that this is not like a monitor. Like as soon as something being tested here is no longer true because of the statements in here, it doesn't mean that it immediately jumps out. It waits until it executes the entire block and then comes back up and tests it one more time. So a common use of while loops is to count something, and they all have a sort of a common structure. Typically you set up some sort of counting variable, and then you have your while, and you test the condition. So while counter is less than 5, for example, we want to repeat. Then we set up our statements that will be repeated. And in here I'm going to print out the value of the counter. So maybe I'll say counter is counter, and then I need to increment the counter to the next value. This is the increment operator. Plus plus basically adds 1 to whatever this variable is here. So if I were to run this, let me shrink that down. We start counter at 0, we print it out because 0 is less than 5. We add 1, we come back up. Is 1 less than 5? That's true. So we print out 1. Add 1 to counter is now 2. Check the condition. Is 2 less than 5? That's true. Print it out. 3, 4. And then when counter becomes 5 here, we say is 5 less than 5? That's not true. We skip over the code block and we do whatever follows, of which there's nothing, so the program stops. I want you to, there's a lot going on here in some ways, but again, you sort of need a little mental checklist as what's going on. You initialize some sort of count, you test the loop condition, and you increment the counter to the next step. This is a great place to exercise skills in tracing the execution of code, make sure you understand what's going on. So for example, if I change that to a 1 and change that to 11, what would it do? Well, it starts at 1. Is 1 less than 11? That's true. Prints out 1, goes to 2. Is 2 less than 11? That's true. Print out 2, counter becomes 3. Keep doing that. Eventually counter is 10, which is still less than 11. We print it out. Counter becomes 11. Is 11 less than 11? No. And we're done. And so in fact, maybe I should add in a little line here, just saying done, just to make sure you understand that there's something that can still happen after the while loop. And if I run this, we get 1 through 10. And again, normally, it's good to write these down and just kind of track them very carefully and make sure you understand how this all works. Note, it doesn't, if you use the less than, it doesn't actually hit this value, right? It tests it and skips over it as soon as it's like that. And this is more common than, for example, saying something like this, while it's less than or equal to 10. And again, it's sort of a convention. It both work the same way essentially here, but we usually put in an upper bound value here that doesn't get used as opposed to using less than equals. And we'll see more examples of this and see why that's true. It's pretty common to forget some step. If you forget to initialize the start, Eclipse will yell at you because counter doesn't exist. It's also pretty common to just skip something like the increment. And if you do this, you get this repeating infinite loop. Counter stays 1 the whole time. 1 is always less than 11, so it just loops forever. This is called an infinite loop. You might wonder what you do in this case. You don't have to reboot your computer. There's a little red square here, stop, and I can stop the running of the program even though it's not done. So anyway, you're likely at some point in your life to forget the increment and end up with an infinite loop. While loops are actually very general. The counting form is one thing, but for example, you could have a loop like this: while game not over, do the next turn. And the question is, what is happening here? This is a call to a method. It has to return true or false to fit inside the context of a while loop. And so this might be some code that checks to see if you still have lives or you finished your objective or something like that. And so as long as that game not over returns true, then it will do the next turn. And as soon as the game not over is false, in other words, the game is over, it will skip over and you can have a ending screen or something like that. Also, instead of just counting up from like 1 to 10, you might have something like you want to do some action on a variable and you're not sure how many times it should go, but you want to stop as soon as some condition is hit. So here, when we say while the value is less than some big number, make it bigger and bigger and bigger. We don't know if it's going to go 10 times or 100 times, but eventually this condition will be false and it will stop doing this. And so again, the counting one, you sort of know how many times you want to go from 1 to 10. This is an indeterminate loop where you're not, you don't really know how many times you'll go, but you know when you want to, when you want to keep looping and when you want to stop. And the same kind of thing here. So while loops are used in a lot of different contexts, these forms are actually more common than the counting one, and we'll see why pretty soon when we learn about for loops. Thanks.